Okay, so we're starting chapter 8. Chapter 8 is a really important chapter for you to understand the concepts and ideas behind, because we are going to use the chapter 8 skills pretty much for the rest of the year. Okay? So this is not going to go away. A little bit is going to kind of go away, but the overall bulk idea of the chapter, it's going to stay with us. So if you have questions, you need to ask. It's not a difficult concept, but it is the very beginning of the concept. So if you have questions, don't be shy. All right, we're going to be talking about adding and subtracting polynomials. Okay? And so a polynomial is going to be the sum of one or more monomials. So think about what just got said. The sum of one or more. Well, the sum means the adding or subtracting, right? Because I could add a negative value, right? Some people call that subtracting. Some people call it adding a negative. So the plus signs and the minus signs that are in between each of the little groups are called terms. Those are called terms, each term. That would show the adding or subtracting of a monomial to another monomial. Okay? And we talked about monomial meaning one term. Then if you have something that has two terms, we call it a binomial. Think of a bicycle. It has two wheels. And then we have a trinomial, which has three terms. And once again, think of a tricycle. It has three wheels. Okay? And the idea here is that these are the special ones. So you have a single term, which is a monomial, a two-term, which is a binomial, a three-term, which is a trinomial. If it has more than three, we just call it a polynomial. After three, everybody's lumped into the big generic polynomial group of things, okay? Now, within this group of identifying the polynomials, they're going to ask for some specific details. One of those details is going to be the degree of the monomial, or the degree of the polynomial. So we're going to start with the monomial degree first. The degree of a monomial is going to be you taking the exponents and just adding them together. That's it. Don't make it difficult. Just add the exponents on the variables and only the variables. The constants, which are your normal numbers, plain numbers, counting numbers, integers, and or your coefficients, and coefficients are that number that's out in front of everything. They all have a degree of 0, so we don't even bother with them. That's why we only have to worry about the variables themselves. I'm glad that fell on the floor there, okay? All right, let's look at the first example. So if we were to look at this first example, I've got 8x squared y to the 4th. Is this a monomial?
No, because it has a 4 in it, it's still just 6.
Do you see a plus or minus sign?
Yes.
Oh, no.
No.
There's no plus or minus sign, so yes, this is a monomial. It is one term. Now, if it is a monomial, you have the right idea. The degree on it is going to be a 6 because you're adding just the exponents on the variables. Yes, ma'am? Because that's what it's called. That's what it's called. We're not identifying each individual exponent. We're looking at the collective degree. They call it a degree of the collective group there. Okay? It's just a label. It's just something that if I needed you to identify the degree, you would be able to tell me. Because eventually, in big math, that's going to come in later. Yes, sir?
So, because there's only one 8, it's a monomial, but if there was 2 8s, it would be a binomial.
It depends on how the 2 8s were put in there.
So
Do you see any pluses or minuses?
No.
It's a monomial at this point by definition. Okay?
What if it's like 8 plus 8?
That's got a plus sign. That's now two terms. The plus signs and minus signs are going to separate. We're going to get into it more. It's going to become more clear soon. Okay? So just stick with me. All right. So this is a monomial. The coefficient here, this is a coefficient because it's out in front and it's attached to the problem. that degree would be a 0, so we don't care about him. And at this point, we would just add our exponents together. So the 2 plus the 4 makes a total of 6. So I would say that this monomial has a degree of 6.
Why would it be a 0?
Because all constants or coefficients have a degree of 0. That's the rule. It's not their exponent, it's their degree. Don't get the two confused, okay? This, on the next problem, notice it's just what we call a constant. There's no variables attached to it or anything else. It's just a, quote, constant or normal number, like I like to say. And so it would have a degree of 0. Okay? Then if we look at this next problem, this is still a monomial. You don't see any plus or minus signs. So it's one term so far. And they're saying this has a degree of 3. Does anybody disagree with that? Okay. Does anybody see something that we could work on, though?
Just take the y out.
Okay. And I just want to kind of show you that it really doesn't matter if you just added the exponents on these two variables, because that's what they said to do, right? Just add the exponents. What is anything to the 0 power?
1.
A 1. So I basically have x to the 3rd power times a 1. What would the degree be on this, what we call constant?
0.
A 0. So it really is a degree of 3, isn't it? When all things are, even if you simplified it, you still got a 3. Does that make sense? Okay. Now, here's where it gets tricky, and they're going to ask you, is this a monomial? And it's going to be weird like this. So look at this carefully. You think it might be. Why? What are the things that would make it possibly, yes, be a monomial?
There's no plus or minus.
There's no plus or minus signs. I like that. So it seems like it could be, right? What could prevent it from being a monomial? The negative exponent.
Would you put it in the bottom?
You would put it in the bottom. And that's what's going to cause the problem. Okay? Because we know we can't deal with the problem as long as it still has a negative exponent. So let's simplify this so you can see visually what happens. 5 to the 2nd power becomes a 25. And where does a to the negative 3 wind up having to go to become a positive exponent?
Bottom.
To the bottom. So you now have 2a to the positive 3. Well, what seems wrong with this? Anything? Yeah. Well, yeah, but that's not going to change anything. That's going to still be okay. There's something that's big and bad and very wrong here. We've talked about it before.
The bigger numbers be at the bottom.
No? No, there was no adding happening. It's up there. No. Say it louder.
Variable.
The variable is on the bottom. Remember, if we divide by a 0, all things are horrible in the world, and it starts spinning crooked, and, you know, your calculator cries, and things happen. You get a divide by 0 error. What would happen if I said, oh, yeah, that's an awesome problem, but could you please make the a 0 for me? And now what's going to happen? You would have 25 divided by 0. If you put that into your calculator, things are not pretty. Okay? 25 divided by 0. Oh, well, how about 5 divided by 0? That works too, but okay, 25 divided by 0. Guys, in mathematics, we never divide by 0. Never, ever, ever, ever. If there's a way to create a 0 in your denominator, bad problem. Bad problem. You have to put limits on it. You'll learn that later in Algebra 2. But right now, it's just, we're done. Can't do it. The answer's going to be no. Okay? So, this might appear to be a monomial visually, but if you think it through, the answer is no. This is not a monomial because of the variable in the denominator. Okay? Variable in denominator. Keep that in mind because you're going to have a couple problems on your homework they're going to ask you. And they're going to have some similar circumstances to this. All right. So now let's look at a degree of a polynomial. Okay, now remember poly means more than one. It means many. So I'm going to have several terms now. And I have to figure out what the degree is for the entire problem. Now it's a piece of cake, but I want you to try to not get out of control here, but try to have a little bit of fun so you'll remember it. Let's think of like 21 Pilots. How many members are in the band? Three or four, something like that, right? It's like 3 or 4. I can't remember exactly. 4? Okay. So that would be a group, right? And if we 21 pilots.
There's 21 people.
No. 3 or 4 is what we said.
Wait, is this an airlines place?
No. This is a band. A current band, okay? All right. So if we need to go back to some group that I like, you know, we could go with En Vogue or The Temptations or something like
Maroon 5.
And Maroon 5, okay? Okay, so anyway, what I'm talking about here is a math problem that has more than one member. It's not a monomial, it's a polynomial. And not unlike a band, you kind of almost have to have one person who's kind of like large and in charge. Because if you don't, you have too many bosses and they start fighting and they break up and everybody goes solo, right? So your polynomial must have one term that is large and in charge. And whatever his degree is determines it for the entire polynomial. So whoever gets the biggest number is going to be the lead in our band, in our polynomial band. Okay? So let's look at this and see what we can do. If we look at this particular example, how many terms do you see? 2. Very good. So I'm going to split them so I can see them more clearly. And now I'm going to figure out what the degree of each of the individual terms is. Okay. So will the 8 have any degree?
No.
No. So what's the degree of the first term? 6. What about the second term?
7.
A 7. So who's the big guy? The 7. So 7 is what we would consider to be the degree of the polynomial. Biggest number wins. That's it. Don't care what all the little guys have. The biggest one is the winner, and that's it. Okay? Let's see if you can do the second problem. Do you agree with it?
No. Well, there'd be 2 like hashes. Like 2
Okay. How many terms are there? Okay. So there's 3 terms. Very good. So we would call this a trinomial, right? What's the degree of the first term?
3.
Oh, good. Who said that really loud?
It's 20. That wouldn't be that hard.
Yeah, because that's a constant.
Who, you said it? I want to thank you. I'm going to give you candy. Maria, you're getting candy, okay? Now, hear me. It's the right, wrong answer. I needed someone to give me the wrong answer, and you did. And I'm proud of that, because it means you were thinking clear, you were thinking, okay? All right, so let's talk about why it's not a good answer. Shh, you need to be listening too, okay? Don't get carried away. Do not automatically just jump and start adding exponents together just because you see them. You need to add only the exponents that are on the variables. This exponent turns it into a 32, so it doesn't count. It would have a degree of 0. So what would the degree of this first term really be?
3.
A 3. How about the second term?
2.
And the last term?
0.
Okay, so let me finish my sentence and then I'm going to take your question. So who was the largest degree here?
3.
The 3. The first term had the largest degree, so the degree for the entire group is 3. What is your question?
So if a big number has an exponent, it's a 0. Like what you're saying.
Don't say the big number, any number.
So,
A constant is not allowed to have any power.
so if it has like the number 2,
Yes.
it has an exponent, it has to be 0.
Yes, because all constants and coefficients have a degree of 0. Okay? All right. So are you kind of getting the hang of that pretty well? All right. let's look at the next section and pay attention. Don't talk back and forth to each other because that's part of a problem. Okay? So pay attention up here. Now, the polynomials that have only one variable in them need to be written in standard form, and we're going to be using standard form a lot. So, and what that really means in basics is you're going to put them in order based on their exponents. The biggest exponent down to the smallest exponent, and your constant number will be the final number. So the number that has no variables attached to it will always come at the end. Okay? So if I look at this example, notice that this is what we call standard form. I have a 4, I have an x to the third, an x to the second. This would be an x to the first, and then my constant is at the end by itself. That's standard form. Once something is in standard form, they can ask you what the leading coefficient is. Well, that's asking you what number is leading the problem, and the answer is 4. Okay? If that had been this is a what if. You need to stick with me here. What would you tell me the leading coefficient would be of this particular problem? -1. Very good. It's not a variable. It's the number that would be in front of the variable if you could see it. Okay? So don't get caught. See if you can put this triad in standard form and tell me what the leading coefficient is going to be. Because this is what about a third of your homework is going to ask of you. Put it in standard form, largest exponents to smallest exponents, and then tell what the leading coefficient is. So who has the first term? Say it.
4.
The 4x to the 5th would be your first term. What would come next?
3x.
A positive 3x squared. Good. And finally? Minus 7x. What is the leading coefficient?
5.
That's
4. 4.
It is a 4 because it is a coefficient, not an exponent. You put them in order based on the exponents, but the number that's leading the group is the leading coefficient. Okay? What's interesting about this particular triad?
That's a -9.
No. Well, it is a -9.
Only one with the big exponent.
Okay. What else?
There's two that only have one.
There's 2 that have exponents of 1. We need to combine like terms. So make sure you simplify it as much as you can before you put it in standard form. So I'm going to rearrange this. I have a -2y to the 4th as being my first value. Now I'm looking for a y to the 3rd. Nope. Y to the 2nd. Nope. Y to the 1st. Yes. Positive 5y and a -6y. And then I have just my -9. You must simplify your stuff. So combine like terms there. You'd have a -2y, and what's going to happen to those guys? -1y, good, or just -y, it's your choice. I forgot my 4. And then a -9. Did you do okay? And what would the leading coefficient be? -2. So your leading coefficient would be a -2. Your homework's going to ask you that, and it's going to be worth 2 check marks tomorrow, so do be careful. All right? Any questions so far? Kind of pretty okay. You're mostly putting things in order based on the exponents. Okay? All right. Now, the last half of this, the front of these notes, is talking about what really is going to be lasting you into the next month in Algebra 2 and Geometry. Finding the degree is something that we'll do kind of for this lesson, and then you may come back and talk to it later, but not much. But this part here, learning how to add these things together is huge. And I need you to really understand what I'm talking about, so bear with me here for a second. For example, if I had 2 cows plus 3 cows, what would you tell me my answer is?
5 cows.
Very nice. You did a great job. Now, I know it seems very basic, but it's a huge concept. So think, and you thought of cows as a label or a thing, right? You added things that matched together. When you're adding your variables, you can only add things that match together, and you don't change them. I didn't say my answer was 5 cows. Did I? No, I left it as the original value, kind of like a label. So if you're adding things together like 2x squared plus 3x squareds, those are kind of your things. Those are the things that you have. How many of these things do you now have?
4.
You have 5 things called x squareds. Notice you did not change your exponent, did you? You are not dealing, just think of it as a label when you're adding things together. That's really important for you to kind of understand. So let's look at the try it now. And if you want to regroup them like this, you can. I hate this, but it's your choice. I think that if you just mark them so that you know you've dealt with everybody, that's fine. And if you're someone who likes colored pencils, or you get lost easy, or you need things to make things more orderly or clear to you, use some colored pencils in the beginning until you get good with this. For example, we need it to be in standard form, so I need my biggest exponents first, so that's where you begin. What's the biggest exponent in this entire problem? The biggest exponent.
2.
A 2. So I need everything that has an exponent of 2 to be added together. So I'm going to go, okay, I see an R2 there. Yeah, R2D2. And an R and a plus 8R here. So how many R's are really in this one?
9 R2.
This is a 1, and this is an 8. So if I add them together, I would get my 9. And they were called R2s. So now what R's need to be coming next? R to the first power, right? So I'm going to look at my problem. Okay, I've got 1 there, and I've got 1 there. So I have a positive 7 and a negative 2. What would that become if I add them together? A positive 5R. And then I have, I'm going to do a double line here, a positive 11 and a positive 10 would turn into a positive 21. I put it in order, and I'm done. Okay? Notice those guys did not get added together, did they? Their labels are different. They're different values. You cannot put bikers and ballerinas together. No. They have to be the same to be put together. See if you can do the try it real quick. What's the biggest exponent?
3.
3. Look carefully. Find the biggest exponent and put them in order based on their exponents. Bless you. Bless you.
Told you that.
After an exponent of 3, what comes after that?
2.
A 2. So I'm going to search out all the things that have an a squared. Got that. And I've got that. So I have a negative 5 and a positive 1.
Negative 4.
Yep. Now I'm going to look for a's to the first power. So I've got I'm going to circle that one and that one. So I have a positive 1 and a negative 4. Negative 3. And then I have this poor little lonely 9 all by himself, and he was positive. sense?
Yeah.
Okay. Just don't entertain him, okay? Just don't. All right. If I could get down on my knees and get back up again without assistance, I would be down on bended knee right now, begging you, and I mean begging you on this next section. Don't take a shortcut. I have taught this too many times. I've seen it over and over again. And if you make this shortcut mistake and you start doing it now, it is going to continue to follow you throughout your math career, and you are going to be in a world of hurt in a couple of years. Okay? Take the extra 10 seconds it takes to rewrite the problem before you start adding terms together. I am begging you. And that is when you have a minus sign. Okay? So notice in this second example, I have a group of values minus another group of values. I have parentheses. You need to do the distributive property, then combine your like terms. Some people want to do this in their head and just go, oh, this minus this, and oh, this minus... Don't do it. Do not do it. You will mess it up. Distribute and remove your parentheses first. Now, this first set of parentheses, there's no plus or minus, there's no numbers out in front. So you can completely remove those. That's fine. So that would be the first thing that I would do, is rewrite that first set of parentheses without the parentheses around it. So that's what I would do. Here is n to the third power plus 3n minus a 9. And now you're going to do the distributive property. A negative times n is a negative n. A negative times a negative 2n is going to become a positive 2n to the third power. And your last term, negative 1. That does not take that long to do, but it is a huge thing if you don't do it. You're going to mess things up. Now you can combine like terms, and once again, you're looking for the biggest exponents first. So 3 is going to be out in front. So I've got 1 there, and I've got 1 there. So 1 plus 2 makes 3 things called n to the third. Do I have any n to the seconds? No. So I do have any n's to the first?
Yes.
Yes. I have a positive 3, and I have a negative 1. So if I add those together, it's a positive 2 with an n. And then I have a negative 9 and a negative 1. Same signs, add and keep.
Yep.
Different signs, subtract. Keep the sign I had more of, then I'll be exact. Okay. See if you can do the try it. Are you cool with this answer?
Yeah.
Okay. Notice how I made all my different shapes?
Mhm.
That's something I do, and even if I didn't teach math, I would still do that. It helps me see things better, and it helps me find things I might overlook. So see if you can do this, try it, and then you'll be ready to start your assignment.
Wait, why is it didn't you put the 17 in front of the 6 as the basis?
I haven't started rearranging them yet. All I did was rewrite it without the parentheses. There's your answer. You didn't get that? Did I mess up somewhere? It's morning. No, I'm good?
You're good.
Okay. Okay? Alright, so you get the idea? Okay. If you'll open your book to page 468, I will help you with the first two, because they're like, is this a monomial, yes or no? I'm going to get you through those two, and the rest of it's pretty straightforward like this assignment, okay?